Yes.
Yes.
Yeah.
Good. Great. So welcome everyone to the last ROADEX webinar for this year. Next year we will continue this webinar. And today we are talking about winter maintenance and payment life cycle costs. And this is a very wide area. I can scratch only a little bit about the surface of this issue. And when we have 30 to 45 minutes time, so I've been getting some research information and experiences from several sources. First of all, from the ROADEX projects and ROADEX network, even starting from 1998. Then PEHKO project results from 2015. Aurora autonomous driving test project and infrastructure projects that we have been doing research with Tampere University and Terra Research Center. And then there are a few cases about experiences of our Roadscanners' own R&D projects, especially projects related to moisture damage index and then road doctor maintenance controller real-time maintenance follow-up project that we are now working. So the summary and experiences are from all these projects. In general, winter maintenance, talking about ROADEX history, winter maintenance was very actively reviewed in the first ROADEX project from 1998-2001, and we made a report about winter maintenance practice in Northern Periphery, and then very good research about generation of smoke and behind heavy vehicles and others. And but after that winter maintenance, it was concluded that compared with Ireland and Scotland, and on the other hand Sweden and Finland, the environment is so different that these winter maintenance practices are slightly different. And then we decided that okay, we will continue focus more on seasonal changes and road condition management. But still there's this ROADEX 1 project problem identification. What we found out that drainage in sloping hills and permanent deformation due to the freeze-thaw cycles were very much related also to the winter maintenance, even on the beginning. Later on, after this, all these 4 ROADEX projects, we made this summary report that where we said that if we want to improve the productivity of asset management, low volume road asset management, we need to have better maintenance practices, focused rehabilitation design, having a monitoring, and maybe having more road-friendly vehicles. So that was the summary. And these summaries and experiences started to do a pilot in Finland in 2015, what was called PEHKO project through what is now Väylä, Finnish Transport Infrastructure Agency, and then this ELY Center from Lapland and Central Finland, and from 2018 also ELY Center close to Helsinki, this Southern Finland. And our final goals was based on these ROADEX recommendations, was that in 2025 the road network should be a better shape and annual paving cost even 50% lower than current level, which was calculated in 2015. So how we wanted to make that, this have been already shown earlier, so I'll go quickly through. So these road maintenance standards should be improved. We should be using new technology in order to focus on these weakest sections and then moving more towards proactive maintenance. And even over the first 2 years, we made a very thorough analysis on the reasons for the problems paving backlog. First of all, where are these expensive sections and what is the reason for them? We found out 7 reasons, major reasons for that. 3 of them were related to pavement structure. I'll skip on them. 3 of them daily maintenance, and actually the 7th one was also slightly and pretty much related to winter maintenance, but I don't have time to go through this issue on today. But this daily maintenance problem, drainage problems on private access road junctions, drainage problems on side ditches, and then winter drainage and especially delayed removal of snow walls in the road shoulder. So these 3, and I'll tell more about them. So first of all, going to private access road junctions. So in ROADEX 3 and 4, we did quite much research on drainage, and also in ROADEX 4, we had the pilot areas that we separately reported. And here's just front page of a pilot and drainage pilot in Rovaniemi area, here in our Roadscanners hometown, and how we were monitoring the special drainage sections that we identified, and how we were monitoring them. And these results, and when we did regular monitoring certain roads for a few years, what we found out was that surprisingly big amount of the problems on the road could be related on the access roads that were clogged or frozen, and when they were frozen, all the water was infiltrating under the pavement structure and causing frost heave. And here is just one example of road 934 north from towards Kittilä, north from Rovaniemi, in this road section 3, when we analyzed all the access roads. So 54% of all the access roads had the differential frost heave due to the problem with the drainage. So more than half of them. So it was a very, very, very big issue. And actually, this research related even to change of the Finnish law. And because before that, the law was that the private access road owner should take care of the maintenance. And when everybody realized that the private access road owners don't have a know-how and technology to do that, so that was transferred to the responsibility of a road owner. Later on, when it was expanded this to PEHKO project started, and when it was expanded to even Uusimaa, close to Helsinki area, we found out that this problem is not related only on the central or northern part of the Finland, but it's everywhere. Here's an example of private access road problems in Uusimaa area, close to Helsinki. And again, very typical problem. We have a private access roads here, and extremely heavy deformation, which ends after the access road. And you see also on the bearing capacity indexes that this is a weak and saturated subgrade and structures in this area. Also, one issue what we have been finding that this is extremely a big problem when your private access roads comes higher from the higher level than the grade line of the road, because then all the snow and water from this access road, that ditches are flowing to and hitting this road. A very good example of this is a case from north from Rovaniemi, also in the PEHKO area. One road that was paved and immediately after that you started to have frost heave issues. Here's an access road that coming up from the hill, another photo. So you see quite much also water, snow from the access road also plowed, and this when it's keeping so quite much water, snow is stored in this area. Also a picture from the other direction from this section, and here you can see the same intersection or intersection from summer. So you don't see culvert here, and also that the water from these ditches are flowing both sides on these sections. And when we measured this condition of the road, so for instance, roughness in the winter 2017, summer it was okay. In the winter 2007, you see so very high pumps in these sections, in this section. And when we measured the moisture damage index, which measures the moisture content like of free water in the pavement structure, what you can see in 2017 winter, this time that we were measuring extremely high unfrozen moisture content on the area where these pumps are. And this MDI top means that it's a top 30 centimeter. It tells that these ICELENSES are very, very close also to the road surface. One more finding supporting this theory that the problem is winter maintenance problem can be related to the access road is this road doctor maintenance controller acceleration sensor, this real-time monitoring of maintenance. Here's an aerial photo and acceleration data from the same road that you saw before. And these red circles are where the acceleration is more than 14, and what we could see on this that most of the uneven spots could be related on the areas where you have access roads. So this was a very common trend still. So now we were talking about unevenness, but it's not only the bumps the issue. And here's an example, a map from the Central-Finland PEHKO area, and in this area when we were calculating the annual RUT increase. So we made an analysis also where we compared the annual RUT increase on the area of private access road, compared that with the areas around a little bit further down, and these results were very, very interesting. And when we ranked all this, starting from the worst private access road towards the best ones, the results showed that in the 100 worst access road, so annual rutting was still 7 millimeter per year, which means that you have only about 3 years lifetime before you should be patching when you start to get more than 20 millimeter of rutting. And when we went to the access road number 500, it was still 3.5 millimeter per year, which is still only about 5 to 6 years payment lifetime, when the average value were much less than 1.5 millimeter per year. And actually, as you see later, that most of the rutting is less than 0.5 millimeter per year, indicating more than 30 years of lifetime. So these guys are really weakest links. And when you calculate them as a function of a paving backlog, it was about 100,000 euro per year, which was more than 10% of the annual paving budget in this area with 400 kilometers of roads. And especially when knowing that it's actually keeping the culverts clear is not a very high cost. So this data shows that it's a quite big issue and also affecting the payment life cycle cost, keeping these roads, access road culverts and access road intersections clear. Just a couple of slides also, another very interesting finding relating to the how do you store snow on the areas where you have more snow than everywhere else, was the finding that we made also on ROADEX 4, that at the end of rest areas we could find very often areas where the rutting was about 3 times higher in this area, and many often there was a high IRI. And when you made the photos, you could see this kind of pavement distresses also on the parking area. And the reason for this was very much that during the winter time, when the snow clearing machines were pushing the snow, they were storing the snow here. So there were big stockpiles of snow in this area, and they melted. And when they melted, all the water was infiltrated under the pavement structure and causing these problems. This was a little bit forgotten until we started now to do the work also on this real-time road condition monitoring. And here is last spring, again from Lapland, and this black area means that your acceleration is more than 16, which equals maybe IRI around 5 or 4 to 5, so quite rough areas. And I took one test road where we've been driving with this car under the testing and pick the first. This is from the not from the Rovaniemi. I picked the first area where you have this bad roughness issue, and once we get the photo also that takes the photo from the same place. What you can see is a private access road, or no, rest area, end of rest area. And then when I followed back towards Rovaniemi and took the next black section here, again it was on the end of rest area. So and also in other areas what we have been finding this. And again the solution is very much that in the guidance you shouldn't store snow from this rest area in this area, but push them further down that they are not infiltrating on this area, because that seems to be always causing problems. Then we go to the third area, delayed snow removal from road shoulder. First indications we got this in 2014 when we did in southeastern Finland, close to Kouvola area, some tests, and And we measured the same roads in April during the thawing period, when thawing period started, and then again in July. And at that time, we were developing this moisture profile, moisture damage index, showing with the GPR, showing where you have an excess amount of water in the pavement structure. And they can be seen as a red and black in the pavement structure. And what was the interesting finding was that exactly on these sections where you could see even in April that snow walls were not removed and there were water in the pavement structure, you could see also this water in the GPR data, in the pavement and under, and exactly on the same spot, you could see higher deformation or higher rutting in the laser scanner based rutting map. So we thought that, okay, this is a very interesting and nice correlation on these phenomena. What we started then in PEHKO and first spring in PEHKO year 2015, we started to do the monitoring. And one issue what we found in many areas that this spring, when spring in March, April came, so maintenance, snow removal started only when it was enough or it became really warm. And at that time, it caused that, okay, all the pavements were wet, and especially close to the road shoulder, there were a lot of ponding, and that means that the water was definitely going into the pavement and into the pavement structure. And based on this earlier finding, we thought that, okay, we need to do something on that. So first, what we did was that we started to do analyze the statistics about snow depth. That when the snow depth in general is increasing and when the snow starts to compact or thaw. And what we found out that in northern Finland, this limit seems to be early February. That snow depth is increasing until early February, then it stays the same, and you have already first warm periods, and that means that, okay, snow is starting to melt. So the decision was that until in early February, we have to reduce the snow wall depth down to 20 centimeter. Start just to give a certain indication of still about where is the edge of the road. So we needed to leave 20 centimeter. And another issue was that we have to remove the snow also behind the guardrails. And here are some photos about this technology what was done. We did also arrange a meeting arrange a test that we had in the same road section. In the same road, we had a section where we didn't remove the snow in February and where we removed and looked a section. And this is the section where we didn't do this work in February. And the top figures are in March, where you see that you have still ice on the road. And then in April, when it starts to really melt, you start to see these uneven bumps here and there in the areas. Once the reference section where we removed the snow in early February, what we can see in the March, we don't see any ice on the pavement structure. So it's clear and safe, looks good. And in April, we don't see these uneven frost bumps in the road shoulders at all. And based on that, we in all these areas we changed the protocol that okay in February the snow is walls are lowered out down to 20 centimeter, and then in March you totally remove the snow. Everything went quite well, pretty well until 2019, winter 2019-2020. And here, this is in Central Finland, and here you see in the light blue color again a very typical average snow thickness, showing again that okay, it's up to February, and then it starts to say thin and then start to melt in March. This is a typical, or this is a 2018-2019, and here you see on the red dots is average from the last 30 years, the trend. But 2019-2020 was totally different. So what you see here was several warm periods where the snow totally melted away. And now the maintenance, in the maintenance contract, the contractor didn't have time to react on this snow melting. So what we got is already about 70 centimeter of snow melting in the road shoulders and infiltrating on the pavement structure. This is the temperature profile at the depth of 15 centimeter up to 1.2 meters. Here you see the frost line, and what you can see that on this, in the first area we got slightly melting number here. It came immediately back, but these two and 3 and even 4 we had real freeze thaw cycles up to 20-25 centimeters. So the pavement structure top part melted at that time before freezing again. What happened then, what we found out, that again talking about this annual RUT increase, which is a clear function of pavement cost, was that when we had in main highways less than 0.5 millimeter per year, we had the roads about 50 to 70% on main highways, and aerial roads we had about 70 to 80, and connecting roads even 60 to 85%. They dropped down to the level of 20 to 30%, and this amount of this very quickly rutting road section increased from 1 to 2% almost to 20%. So it was a very dramatic change on the rutting in 1 year. And then the last one is that luckily and we knew that okay, last winter was much easier, and then again it came to the normal level. Here you see the annual RUT increase measured as a 10-meter value in that problem winter, and then in the last winter, where you see that yellow, mainly yellow, which is that less than 1 millimeter per year. Here you are measuring 2 to 3 millimeter per year. And what was interesting also that in many roads, what you could see that the highest rutting was towards east, where the heavy timber trucks were driving, and towards, because all the forest industry is in the east from this Karstula area. So what we could clearly see that those roads that had a more heavy traffic, they were suffering most on this spring. So obviously we had a permanent deformation issue. And when we calculated them as a cost, what we could found out that in when this 400 kilometers, we started from calculated cost about roughly 1 million euro per year, and we could go down even and down to 0.6,600,000 euro, which is about 36% savings already. We were approaching this 50%, and then suddenly we were even in the higher value than where we started. And this difference was roughly €500,000, which means that we got more than 2 millimeter, more than €2 per meter extra cost related to this snow removal. When in general snow removals is probably the cost for snow removal per meter is something like 3 cents. 3 cents to 5 cents per meter. So it was a big issue. And finally, luckily, last spring, this is a rough estimate. We haven't got the real figure, but right now we are back in this value of 600,000 to 700,000 euro per year. But this was also when we started to do a little bit more analysis on the other roads also, that because we knew, especially in Lapland, that in the winter 2018, we were already reporting that there was also delays with the snow removal, and we could find a lot of water in the pavement structure. We went and looked at the roads that were paved, and we find out also very interesting big dip on these areas. So here was a road that was paved in 2016, and it was slight increase on the share of 8 millimeter rutting, which was 20%. But in that winter, it went from 20% to 90% of a road section more than 80 millimeter. Same on another road. In the same, we could see big like a jump on the relative amount of 8 millimeter rutting. So what we could later on see that we probably show the same phenomenon also on these roads. So a little bit about what happened over there. So this is a little bit new research results and new theory also on this, because earlier what we have known that we've been assuming that we have this primary frost heave, which is expansion of material, which is roughly 9% material expanded when it's frozen. But then mainly we've been talking that we have only the secondary frost heave, which is ICELENSES in the road structure, pavement structure interfaces or deeper down. But now and there is a new type of frost heave and ICELENSES is this what is called tertiary ICELENSES, and it is introduced by Luleå Technical University, and they are called them as a tertiary, and that means that these ICELENSES are growing in the frozen zone. And what is the factor when ICELENSES are growing in the frozen zone? The process is, first of all, this force is called, from the thermodynamic theory, it's called CRYOSUCTION. And CRYOSUCTION means that when you have a CRYOSUCTION, which means negative forward pressure, means that the condition is that temperature has to be below 0 degrees. Then you have to have a unfrozen water in frozen structure, and it's mainly unfrozen water is mainly between 0 and -2 degrees. And then the third one is availability of water, and this availability of water you come from this frozen snow walls. But this CRYOSUCTION is so strong force, and earlier when we were saying assuming that you have to have a frost susceptible material. But this is a research from Texas, and it shows that even a non-frost susceptible material can have a high CRYOSUCTION when it freezes and can develop ICELENSES, and this negative pore water pressure can be really high. So it is American US unit, but suction in PSA, if it's 10, it can be about 500. So it can be 50 times higher than the normally capillary force. It wins 50 times stronger than normal capillary forces, and that is so strong force that it can take water up to 80 centimeters from the road shoulder inside. And here's just a description of that. So once you have snow in the road shoulders, it's minus 10 degrees this is like January, you have minus 8 degrees. Then in February comes first warm days, plus 5 degrees. The base goes under the pavement goes minus 0.5, and it develops and it causes this CRYOSUCTION, and water starts to flow in this area. Then you get another cold days, and they are forming ICELENSES and lifting this road shoulder up. And there is a lot of ice. And finally in the April, May, when this starts to thaw, these ICELENSES, you start to get uneven bumps and you start to see deformation and rutting. This was theory, but in Aurora test site in Muonio, where we could instrument the same issue. Here is April in 2018 and late March 2019, exactly when the warm period started. And you get exactly at that time you start to get this heave, and it was heave. So we could monitor from 30 centimeter from the pavement surface. In 50 centimeter it was a very small, and we couldn't see on 70 centimeter on that. And here's again these moisture areas from the same road section, and what you can see here in March 28 in orange, the snow wall was here, and the next April 18th is here, and here you don't see any moisture content in April when it was thawing, so you have a huge amount of water under the pavement on this side. So basically we could verify them with the GPR and the sensors that this phenomenon really takes place. Interesting finding was also what we have seen in PEHKO, that how local this can be. For instance, reflecting poles earlier, they went around and they were not removed behind the reflecting walls. What we could find out, a frost bump on the each pole, and again deformation collecting water. Here is also point cloud data showing that you are starting exactly on the where you have a reflection poles, you are starting to have a deformation if the snow is not removed from these sections. So coming to the conclusion, so what we know already, that this winter maintenance is it has a surprisingly high impact on our paving costs. What we know from this earlier, that frozen and clogged culvert, their impact on the deformation can be about 10% of the paving cost. And delayed snow removal is what we were calculating, that the cost effect is something like 13 to 17% in general. And when you are doing better winter maintenance, so basically you can cut 50% of the paving backlog, which was calculated to the level of 50 to 60 million. And if it's totally delayed, or we have a very problematic winter like in Central Finland in 1 year, it may even double to annual paving cost. So it is so big impact. And that is thing when we have now climate change. So this kind of winters may come, and most likely this was not the last winter, such winter that we are facing in Finland and Nordic countries. So what we need in the future is that we need to move from reactive maintenance to proactive maintenance. We need to be aware of these processes that are causing this and react them even early before these damages and problems are appearing. And we have to be preventative and proactive. And finally, it is also it's not only question about like money, but we are talking about also traffic safety. Here's one example of 2018 for those outside PEHKO areas, and on the left hand side, and then in exactly the same day inside PEHKO area. So it's traffic safety and drive comfort is substantially different on these sections. Finally, last slide is one issue that we didn't have time to go very much through, but one issue what we have been going through in ROADEX project is also sheet ice or swell ice that are filling the ditches. This the above photo is from spring 2016 when we had issues with swell ice, and then the lower photo I took Saturday, so 2 days ago in Rovaniemi. Now we had a very wet autumn fall with a lot of moisture, and what we can see that it starts to fill, and this is exactly the same effect as with the clogged culverts. So all the moisture are starting to fill the pavement structure, and winter maintenance should be aware of that and proactively start to open these ditches early enough before it starts to affect on the pavements. So that was my presentation today, and if you have any questions, so I'm happy to try to answer them. So thank you. So